everybody, my name is Lena Minghui. Today we're going to be talking about the sun. So in our solar system, the sun is considered as one of the most important stars. And throughout all of these enormous objects, all of those enormous mass out there, yet the sun, although it's not the very biggest, it is one of the very most important star that's affect our life on earth so badly. So today we're going to be talking about the sun characteristics. So first, the sun size is pretty enormous. If we consider it in mass form, then it's going to be around somewhat 300 of the earth. But if we're talking about the size, then we need around 1.4 million earth to fit all in the size of a sun. So imagine the sun is like a bucket. You would need 1.4 million earth to be able to fill the basket. And that's how crazy it is. But do you know why there's such a difference between mass and size? Because the sun is more of a gas object. Why? Because later we're going to be talking about that. But here, the sun is a yellow dwarf star. So we all know that the sun, it is a star, right? Why do we know it is a star? First, it has the ability to shine by itself, right? So it has the ability to shine, it has the ability to produce light. And that's the very most important characteristic of a star, right? And secondly, it does not orbit. It does not have like a whole orbit. It does not have its whole like gravity, etc. So that's the sun. It all has the characteristics of a common star. So that's why we call the sun as a star. And so it is one of the largest stars in our solar system. We're not talking about the Milky Way, we're not talking about the universe, because out there in the Milky Way, in the universe, there's thousands of other stars that are way bigger than the sun. That to us, the sun might be big, but if we actually put that in comparison, it's going to be way much more bigger. And if those other stars were in the same direction and in the same spot as the sun, then our earth is going to get way much more hotter because of how big those are. But let's just talk about our sun amazing characteristics first. So it is composed of two main things, which are hydrogen and helium. So when we talk about the sun, there's this very cool word, very cool academic word, which is heliosphere. So it's all about studying about the sun, studying how's the sun being like, is there anything wrong with the sun? And we're also going to be learning about what changes will happen with the sun, or what will impact our Earth or the planets if the sun is ABCD something. So when you look at the word heliosphere, you see the word helio, right? And when you think of helio, you think of it as helium, right? So the sun is composed of two main ingredients, which are hydrogen and helium. So here is a very not too accurate, but still you could rely on it, map of what's the sun like. So here I've cut it out. I've cut a quarter of it out so we could look deep into it. So here, first, this very deep dark part in the very middle of the sun. What do we call it? It is the core. So it is the very hottest part of the sun. In the core, what makes it so hot is because of the nuclear fusion in this part. All the nuclear of the energy that's going to produce all the light, the heat that's going to be producing from the sun will be produced in the core using nuclear fusion. Moving on to the second layer, here, this layer. You guys can see it. It's called as radiative zone. And this layer is convective zone. So, okay, when we see, for example, this is the sun. This is and this is the Earth, for example, like that, right? It's not really that far, but it's just for example. So if we want to receive the energy, the heat coming from this core of the sun, then all of the light, all of the heat will radiate through the radioactive zone, which is this area, and the convective zone. It will go right through it, and it will be able to spread out all of those light and all of those heat that's stored in the core of it. Alright, now moving on to this very whole part is what we call as the chromosphere of the sun. And on the chromosphere, there's a lot of other things. Like there's sometimes when you look on the sun, you don't see it perfectly. It's not. It is flawed, but you could see on it there's dark spots on it, and that's what we call as sunspots on like the sun, and it's caused by the magnetic force, the magnetic pull of the sun. And on the very outer part of the sun, which is like here, for example, is the sun. So then the part that's radiating off from it is what we call as the corona. So it's not the sun, but it's the part that's outside the sun. Like it's the air, it's the thing that's touching the sun. So it's like the corona. So just for example, our Earth atmosphere, but for the sun, it is called as corona. And the chromosphere plus the corona is called as the atmosphere. So the atmosphere can reach into millions of degrees. So that's how hot it is. So that is the reason why so many scientists cannot put their feet onto the sun, because just imagine, it's only the atmosphere, which is only the very outer layer of the sun, but it's that hot. So imagine inside the core, how hot will it be, right? Billions of degrees, we don't know, but it's very hot. So today we'll talk about the sun. The sun is one of the most important stars in our solar system. It not only provides light, but also heat and life for people in our Earth and for the sakes of other planets too. So thanks to the sun, this really beautiful yellow star that's all built up by hydrogen and helium that have saved thousands of generations' life. Thank you for listening, and goodbye.